All right. Welcome, wonderful people. Let's see what we're doing today. So today we're going to simplify, classify, add, subtract, multiply, and divide polynomials and monomials. Kind of bugs me when people say monomials. I know that a lot of my teachers would say monomials, which doesn't make any sense. Like, why do you have two O's in the same word that make two different sounds? Okay, it's just like Pacific Ocean, right? Every single C makes a different sound. Bugs me when that happens. But I think it's just one of those things that English does. So let's go ahead and get into it. So it looks like we have a lot of stuff to cover, which we kind of do. I'm going to break this into 2 lessons. So let's go ahead and break down what we need to know, the important stuff. So we're going to go ahead and look over the properties of monomials. So what are some things that monomials that we need to know about them? So mono means one. Like a monorail is a type of train that has only one track. A monopoly is when an entire market is basically covered by a single business. So, like, in other words, there's no place else you can go to get something else. Like the same thing. Like I think people were saying Google is a monopoly because they are so large that they basically control everything that has to do with computers and information. And I'm sure you can think of some other ones. Some less common words would be monopod, which basically means like a stick, or a monocular, or what most people would like. It's a binocular, but only one side. Anyway, so a monomial is a number, a variable, or a product of numbers and variables. So we treat them like it's one term. Okay, well, it is one term, but we kind of treat it like it's one number. Okay, so even though here in this example we have one number, we have 4, that's a monomial. Another monomial would be something like 7x. 7 and x, most people would say those are 2 different things, but in this case, because they are multiplied together, we treat them like they are one thing, like it's one piece. Okay. And lastly, I have 3x squared. So you're looking at this and you might be thinking, well, it's got 3 things in it. All right. So we have a number 3, and we have an x or 2 x's, or an x and square. So even though there are several things here, this only counts as one term. So I think way back in the beginning of the semester, we were reviewing basic operations with math, and a term, as I described it then, was anything separated by a plus or a minus. And that's kind of a simpler way of thinking about it. But again, these 3 things here are monomials. So we're going to use some rules here, and these rules are, they look kind of complicated, but they're actually kind of easy. I think you might have covered these in Algebra 1, although I could be wrong about that. I haven't taught Algebra 1 in a while. So this is the product rule. Now, with these 2 things here, we have the same base. We have base A, okay? And we have a to the m power and a to the n power. So we're multiplying these 2 things with a like base. So since the bases are alike, we can use a shortcut, and instead of doing anything else, we just add the powers together. So m, n are just added together. We combine that power so that they are together now. So here's the example that we're going to use for this one. So I have x squared, which I'm going to use this as an example, I guess. So x squared times, so that means I'm going to put a times here, and 7. So here I have a bunch of these here. In fact, let me move it up here because I think I'm going to run out of space here. So there we go. It's going to look something like this if I were to put them together. So I had 2x multiplied to each other because that's what x squared means. It means x times x. And here I have x to the 7. So 1, 2, 3, 4, 5, 6, 7. And they're all being multiplied to each other. And then there's this one here that I'm going to put there because if I look here, the multiplication is still there, right? We still have a multiplication right here. So now I have x to the 9 power because I have 9 x's being multiplied together. So that's why the product rule works. So I know sometimes students, they get confused or they say, you know, why can't we just keep it easy? Well, okay, this is kind of easy, but remember, we're dealing with multiplication. Everything's already being multiplied. So if you're multiplying a multiply, then you're just adding the things that you're multiplying. You're just adding more things that are being multiplied. Anyway, let's go ahead and move on to the next one. Let's go to the power rule. So in this case here, we have a to the m being raised to the power of n. So a power of a power. So when you have a power to a power, so there's only one base here. There's no other a, because if there was another a, then we'd be multiplying bases. But in this case, again, we're taking this power and we're raising it to another power. When that happens, you multiply the powers. Okay, so on this one here, for this, it looks more, okay, so I'm going to use these same things here as an example. And I am going to put them here like this. So I have x times x, which is x squared. And I'm going to multiply it again and again. Okay, move this over. Multiply it to this and this. And I am basically going to do this 7 times over. Okay, oopsie. Okay, this is going to be a little bit tougher than I thought. Let me move that out of the way. So x times x times x. Let's see. Oh no. So it would look like that basically. And I'm all out of spaces, but you can just use your imagination. So if I have 7 groups, 1 group, 2 group, 3 group, 4 group, 5 group, 6 group, 7 groups, then there would be 14 x's. All right, there would be 14 x's. So that's why we have 14 as our result here. Okay, right there, we got 14. Now, following that same idea from the product rule, we have the quotient rule. And this means we're dividing a to the m by a to the n. So if you're multiplying and that gives you adding the powers, then subtracting will make you subtract, dividing will make you subtract the powers. So a over an, or am divided by an, is am minus n. So you just subtract the powers. So here I have x to the 7 divided by x to the 2. So I'm going to go ahead and use my these things again, my examples here. So I am going to write a fraction. So this is what a fraction kind of looks like, right? So I have 7 on the top, 7 x's on top, and I have 2 on the bottom. So this is kind of the way okay, so yeah, back when I used to teach, I think Algebra 1, I used to cover this part too, and that's kind of how I know it's in Algebra 1. So I think what I do, and a lot of other teachers do, is we cancel them out, right? Because we know that by property, if we divide any number, so in this case I just picked 5, so if I divide any number by itself, or 5 divided by 5, it just comes out to 1. And that same thing is true for x divided by x. It just comes out to 1. So x over x, that's times 1. And we know that the identity property says that 1 times anything is going to be that same number again. Again, these are just basic properties. So these cancel out and become 1 times 1, which is 1. And timesing 1 by anything is not going to change anything. So that's why if we look at it, we have 5 x's left. So that's why we have 5 x's left on that example there. And this is a more, in my opinion, a better visual way of explaining it. Or maybe I should just leave those on. I don't think there's any reason to get rid of them. And there we go. So that's the quotient rule, which means you just, if you want to divide the powers, you subtract the powers. Okay, now here's where we get into some that are a little bit more confusing. We have a to the negative m. And this is what we call the negative exponent rule because the exponent is negative. So if you want to get rid of a negative exponent, you do the reciprocal. So the reciprocal is where you flip a fraction. Now in this case, it's not exactly flipping it, although in most cases, it kind of looks like you're flipping them. You're actually switching the sign. So if I have a over 1, like this, okay, so any number over 1 is going to be that same number, right? If I have like 5 over 1, it's still going to be 5. But I'm going to flip it. When I change the position from the top number to the bottom number, the negative is gone. We get rid of that negative on the exponent. So basically, the negative on the exponent is like an instruction. It's telling you to move this number to the other side of the fraction bar. So here I have x to the 2, or sorry, x to the negative 2. And anytime you have a number, a whole number, it's always over 1 if you want to turn it into a fraction. Like I always say, if you wanted a fraction, you should have put a 1 under it. And I'm just going to go ahead and flip this so that we have 1 on top and our x2 is now on bottom. But again, the negative is gone. When you move this to the other side, that's going to cause the negative to switch places from negative to positive. So now it's positive. So again, you just flip it. That's all it is. Anytime you have a negative, move it to the other side of the fraction, and now the negative is gone. All right, let's go ahead and move over to the next one. So we have the zero exponent rule. So zero exponent rule, as you might kind of get from the name, means when you have a 0 in the exponent. Now here I have a to the 0, and a stands for any number. So if I had 100 to the 0 power, it would be 1. If I had 1,000 to the 0 power, it would be 1. Now I guess I could explain this one as well, but this one kind of takes a while. But let me see if I can kind of simplify it a little bit. Why is something to the 0 power always going to be 1? All right, so let's go with 2. I'm going to go with 2 to the 2 power, and we know that that's 4. If I go 2 to the 1 power, that's 2. If I go 2 to the 3 power, it's going to be 8. So if I look at it, the pattern on this side, 8 to 4 is divided by 2, right? And 2 to the 4 power would be 16. So if I look at the pattern, divide in half, divide in half, divide in half, and the next one would be, from here, would be to divide 2 by half. That would be 1. And this is true for any number. Any number. If I pick 3 to the 3 power, it'd be like 27, then divide that by 3, you get 9. 9 divided by 3 is 3. 3 divided by 3 is 1. All right, so everything always comes out to be like this. Now, if I keep going with integers, 3, 2, 1, 0, the next one should be -1. And take 1, divide that in half, and you get 1/2. So this also explains the negative exponent rule. So on the negative exponent rule, the next number, so this would be 2 to the -1, so this would be 2 to the -2. This would be -1, or not -1/4, but 1/4, which is the reciprocal of 4 over 1. You get 1/4. So I hope that helps. I probably didn't need to explain all of that, but that's why it is, okay? And if you're like me, sometimes when you know why something works, it's easier to remember it. Or if you get lost, you're in the middle of a test and you're like, oh boy, what did I have to do with this one? You might remember this or something like it to kind of help you out. It's called deriving your formulas, and it's something that I do this a lot too. Like I don't remember every single formula, but I kind of remember patterns and how the formulas, like say for a sphere, the formula for you know, a prism, cylinder, or anything like that, you know, volume of a geometric figure. Yeah, I don't know all of those by memory. I just sort of think, okay, what are the rules that you use to get to them? Anyway, let's go ahead and go to this, this here where we are going to be using the properties. So when adding or subtracting, combine them as they are like terms. So don't forget, like terms have the same variable, and they also have the same exponents. So like terms have the same variable and the same exponents. Oopsie. All right, so again, most students will know that, yeah, if they have the same variable, put them together. But we don't quite know about the same exponent, so they have to have matching exponents. So if I have something like 7x plus 2x squared, I can't put them together, right? So we kind of covered those in quadratics, that they are not like terms. So be careful, gotta have same letter and same exponent. So let's go ahead and do this first one here. I'm gonna do 5 times -7. So 5 times -7 is -35. Now I'm going to go down the line and do the next one. So x's to x's and regular numbers to regular numbers. So just multiply everything to the other variable that matches it. So in this case here, I have x. So x2 and x to the 6, we are going to have to use product rule. I'm just showing you where the rule is coming from. So that means we add these two exponents. So 2 and 6 become 8 power. So this becomes -35x to the 8 power. Okay, now on this one here, earlier in another class, I messed this up because I forgot to put the 2 in there. I guess I didn't look the problem over close enough, and I just skipped, or actually I kind of worked a little bit. I did the same thing over here, but I just didn't put the 2 in there. So I got to make sure to look these over a little bit more carefully before starting. So here I have 2. Now, whenever you see a parenthesis with an exponent, you might be thinking of using FOIL. Okay, but we don't need FOIL in this case, because FOIL is when you have 2 binomials, all right? When you have something like this, right? So each of these has 2 numbers in them. So x and 3, x and 5. So these are binomials being multiplied. This, even though there's a lot of stuff in here, is still considered a monomial. So again, treated like one number. So I'm going to multiply, well, actually, I'm going to square everything in here. So -2 times -2 is 4. So again, this is a power raised to a power. So we're going to have to use the power rule. And that means that if we're taking a power and raising it to another power, we multiply the power. So in this case, 3 times 2, and that gives us a to the 6. And here we have b, so b, and if you do not see an exponent, it is considered 1. So this is 1 times 2, so we get 2. Now we got to multiply it to this one here, which we didn't have to do anything to because there's not really much going on with it. So let's go ahead and multiply these, again, numbers to numbers and variables to their partner variables. 4 times 8, so that would be 32. A to the 6 and a to the 1, which again, if you don't see an exponent, you consider it to be a 1 power. Well, you don't consider it, it is 1 power. But 1 power is just like the normal way of speaking, okay? It's just like the normal way that you see numbers all the time, so we don't really need to put the 1 power in there. So here we have b to the 2 power and 9. So I'm going to add the powers together, and that's going to be 11. So there we go. There we are done with this one. And I guess I'm going to box this one up too. This was the only thing I wrote in this one, so I thought I could get away with just putting the answer in there. But Since this one has extra stuff, we don't really need that extra stuff. Okay, so with this one here, we are going to need to use our quotient rule, which again means dividing. So if you are dividing powers, you subtract the exponents from the top, subtract this bottom ones from the top ones, or again, move in the direction that you would normally kind of move the numbers in. So dividing it normally. So if I have a fraction of 54 over 3, remember, if you have a fraction, divide it if you can, and if you can't divide it, then try to reduce it. Which in this case here, 54 can be divided by 3. 54 divided by 3 is 18. So I'm going to go ahead and put 18 here, and here I have m to the 6 divided by m to the 2. But again, we have to subtract the powers when we use the quotient rule. So subtract that power. 6 minus 2, we get 4. So m to the 4 power. Now let's move on to the n to the 4 and n to the 1. So 4 minus 1 is 3. Now, all my numbers on the bottom cancel out. I have fewer numbers on the bottom, right? Because I have 6 on top, 2 on bottom for n. N is 4 and bottom is 1, so that means I have more. So if I were to leave this as a fraction, there'd be a 1 on the bottom, but I don't really need that 1 on the bottom because it's a whole number, so why change it? Why make it any different? But we have to subtract this 10m and n to the 3. Now again, like terms have the same variable and the same exponents. So m to the 4, n to the 3. Now in this case here, it looks like I don't know what's going on. I've been kind of spacey today. I don't know why. But that's supposed to be an n, right? N, because again, 4, n to the 3. So m to the 4, n to the 3, same thing. Same variables, same exponents. M has 4 on both of them, n has 3 on both of them. So if they entirely match all of the variables and all of the exponents, then they are like terms, just like if I were to add, any other number together. So in this case, I'm going to take 18 and subtract 10. So I get 8m. And when you subtract it, you're not actually, none of these are going to change. None of the powers or exponents, when you're not going to cancel anything out. So it's basically going to stay the same. Again, if you minus, say, 7a minus 4a, you don't just get plain old 3. The a has to go with it as well. All right, let's move on to number 4. Now this one's kind of a tricky one. I got a little bit turned around on this one with one of my morning classes. So my first reaction was to make this into a reciprocal, but we don't really have to do that. We can use the reciprocal property. What do they call it again? The negative exponent rule. We can save that later, okay? One other thing to note before we begin this problem is that only the k is a negative exponent. Only the k, not the 10. If we wanted both of them to be the exponent, it would look something like that. There would be a parenthesis saying these two things are together. But in this case here, they are not together. It is only the k that has a negative exponent. All right, so let's go ahead and work on this. So let's multiply 2 times 10, so that would be 20. And k, 4 and negative 7. So in this case, I'm going to be using the product rule instead. Now there's nothing saying that neither of them can or have to be either positive or negative. They can or can't, okay? So anything goes. 4 minus 7 is negative 3. So we have 20 and k to the negative 3. Now again, this negative 3 only applies to the k. So instead of thinking of it like flipping or reciprocal, what this means is that the k has to switch sides of the fraction. So here it's on the top of the fraction, because all whole numbers have a bottom number of 1. If I were to flip it, the k is now on the bottom. So k to the 3. All right, and that's it for that one. I'm going to move on to the next one. So we have more monomials. In fact, it's the same exercise. It's the same thing. We just have more of the same thing. So number 5, and again, here's that little 2. Be careful with that. It is easy to miss. So that means I have to square everything inside the parentheses. So I'm going to go ahead and do that. So square 2/3. So if I have 2/3, don't forget what this means. It means 2/3 times 2/3, because anytime you have an exponent, it means that number times itself. So 2 times 2 is 4, and 3 times 3 is 9. So when I square 2/3, I should get 4/9, or 4/9. There you go. And since I'm raising this power to a power, that means I'm going to have to multiply it. So 2 times 2 is 4. And let's go ahead and take care of the s. So s is 7 power, raise it to the 2 power. That means 14. Okay, now I'm going to bring this down. So times it by 1/6, r to the 3rd, and s. So same thing, let's go ahead and multiply these together. And here I have 2 fractions. So 4/9 times 1/6. So to multiply these together, I'm going to multiply top number to top number and bottom number to bottom number. 4 times 1 is 5. 9 times 6 is 54. Now, oh wait, hold on. 4 times 1 is 5. What am I? I must be going crazy. 4 times 1 is supposed to be 4. Okay, so in this case here, I have 4/54. And like I said, anytime you come across a fraction, think to yourself, can we divide it? And if we cannot divide it, then we should simplify it or reduce it. So think about a number that you can divide 4 by and a number that will divide 54. And it has to do both of them. So in this case, it's pretty easy because both 4 and 54 are even numbers. So that should tell you that this number, it should be, we should be able to divide 2 by both numbers. So divide 4 by 2, we get 2. And 54 divided by 2 is 27. And from here, we are unable to reduce it anymore because 2 and 27 do not have any numbers that will divide both of them. But let's get back to multiplying here. So R4 times R3. So we're going to need our product rule and add them together. So this would be R to the 7. And s, so let's go ahead and add the powers of s. So 14 and 1. Don't forget, if you see no power or no exponent, then it is to be considered 1. So in this case here is our final answer. And it looks like we have a fraction, and sometimes it be like that. All right, let's go ahead and move on to number 6. Now this one here has a big -1 covering the whole thing. Okay, we have a big old -1. And that means everything has to switch sides. So that means 14 to the -1 power, w to the -12 power, 7 to the negative 1 power and w to the negative 3 power. But again, we're going to use negative exponent rule. So if you have a negative exponent, switch the side of the fraction that it's on. And again, I really should I feel like I should write all this out, but I'm feeling lazy today. So switch the side, and the top one, because it's negative now, we got to switch the side on that one here. So I have now on top 7w to the third, and on bottom 14w to the 12th power. Now we should reduce this as much as we can. So 7 over 14, again, if that was its own fraction, both of them are divisible by 7, and that means that we are going to have to divide both of them by 7. Oopsie. Make that 2 look a little more 2-like. Now here's a common thing that usually happens, and that is students kind of forget about this. So when you have a 1 over 2 or a 2 over 1, you will get something different. So to help explain this, I'm going to go ahead and go to my calculator. So let's go with 5. So if I have 5 divided by 1, and if this was a fraction, it would be 5 over 1. That becomes 5. All right, because if I have 5 Skittles and only one person to share it with, that being me, then I can eat all the Skittles. So I get all 5 of them. However, if I have 1 Skittle and I divide it 5 ways, each person gets 0.2 pieces of Skittle. So each person only gets a much smaller one. So you can see that which number is dividing which number makes a big difference. So I know that some students might think of 2 over 1 would be 2. So they would think 1 over 2 is 2, but that's not true, because 1 divided by 2, or 1 over 2, is going to be 0.5, which most of us would recognize as being half. So in other words, this stays as half. It does not become 2. Okay, so write a fraction. So 1 over 2, and now we have to look at the w's. Now this one's kind of a weird one, because we would get w to the 3 minus 12. So 3 minus 12 would be, let's see, what is 3 minus 12? Negative 9. All right, so 3 minus 12 is negative 9. But again, we're going to have to use the negative exponent rule. Anytime you have a negative exponent, it has to switch the side that it's on. So w to the negative 9, if I move it to the bottom, is now just regular positive w to the 9. There we go, we're done with that one. Let's move on to number 7. Now again, we also are dividing, so 15 does not divide by 24, so this means that we should try to reduce it. So by reducing it, what number can 15 and 24 both divide by? And this one took me a little bit longer than it should have in an earlier class, but 15 and 24, it would be 3. So I'm going to divide both numbers by 3. So 15 divided by 3 is 5, and 24 divided by 3 is 8. X10 over X2, I'm sorry, X12, X to the 12. 10 minus 12 is negative 2. And here I have 4 y's on top, 3 y's on bottom, so that's 4 minus 3. So that would be y to the 1. But instead of writing to the 1 power, I don't really need to, because if people should know that if you have no power, that you can see on a variable, then it's just 1. Okay, but here we have a problem, and that is we don't want this negative exponent. So I'm going to go ahead and get rid of that negative exponent by moving it to the bottom. So now that it's moved to the bottom, it's no longer negative. And there we go. That's the solution for that one. The answer, it's been simplified. Okay, let's go ahead and do this one here. So this one is a little bit of a confusing one because we have to raise this whole thing by the 4 power. So this will become c to the 4 because we got to raise it to the 4 power. And here I have c to the 2, but it's being raised to the 4 power, so that means I'm going to multiply it out. So that becomes c to the 8 times, and it looks like I'm going to have to do the 4 power here. So this means -3 times -3 times -3 times -3. So I once had a teacher who would always say, when in doubt, write it out. So if you feel like you're going to make a mistake or lose the negative or something like that, just write it out. So -3 times -3 is 9. And we also have another set of -3 times -3, which becomes 9. So I paired these off now, so now I only have 9 times 9. And that would be 81. So go ahead and put 81 here, 81 over c to the 4, because the c also has to be raised to the 4 power as well. Now another thing I'm going to do is I'm going to reduce this. So 4 and 8 can both be reduced, right? We can divide them both by 4. So c to the 1, because I divided it by 4, and I'm going to divide 8 by 4, and we get over 2. Now I'm going to turn this into a fraction just to make things easier to work with. So I'm going to turn it into a fraction by putting a 1 under it. 81 c to the 4. All right, now I'm going to multiply them together. So this becomes 81 c to the 4, or actually, hold on, if I'm multiplying it out, it's going to have to be, oh, wait a minute, no. Oh, wait a minute, no. This should be c to the 4 here. And what that's actually going to do is that it's going to cause this to cancel. So one other trick to multiplying with fractions is cross cancel. If you have 1 on top and 1 on bottom, even if they're not the same number, you can still reduce it just like you would reduce any other fraction. C, and any number, c to the 4 over c to the 4 is always going to be 1. That's just one of the basic properties of math. So this is going to leave me with only the number of 81. So 81 is going to be the only thing that we are going to be getting from there. And we also have one small problem. I didn't want to make a whole page of it, so I just stuck it down here. So here they want us to make a question that comes out to, well, it's got to be a quotient, so this means that we have to do a division type problem. So we have to divide something that will get us -3 times n squared all over m. So what can we do? So this one's a bit of a weird one because it's not really weird. I mean, problems like this kind of happen a lot. But it's a little bit different because instead of looking for the answer, we have the answer and we need a question that will make the answer that they gave us. So we're not simplifying. I don't know what we could call this. We're making it more complicated. We are complexifying. Okay, that sounds complicated, which I guess if that were the real term for it, then it would be appropriate because it's also complicated. All right, so what can I do? I could probably multiply everything by the same thing. So let's see, what can I multiply 3 by? I could probably multiply it by 12. So that's what I'm going to do. I'm going to multiply my top number by 12 and multiply my bottom number by 12. Now you're probably thinking, where is the number down here? Well, same thing. If you have a variable or anything at all, in this case we have m, and there is no number, then we consider that number to be 1. Okay, now I need to multiply m and n, probably to get something different. So I'm going to multiply m by 4. So I'm going to multiply m by 4 up here, and m by 4, since there's already one m, it would be 5. It would have to be one number higher. And if I were to go like this and multiply it out, yeah, it would look like that. There would be more m's on the bottom than there are on top. So that would cause it to have more m's on bottom, or the result of the m's on bottom. All right, here I have 2 n's on top. So this means that there will be 2 more n's on top than there are on bottom. So I'm going to just pick a number. Let's go with n7. Now I need 2 fewer n's, and that would be n to the 5. So negative 36 m to the 4 and n to the 7 all over 12m. M to the 5, n to the 5. Wait, did I just make them both? Okay, I guess that works out. It still works out. But anyway, yeah, if I were to take this, if this was the question and I had to simplify it, that would be the answer. And I think that one would have multiple answers to it. So it doesn't have to be exactly that. If you want to maybe put something different in there, that's fine too. Okay, let's go ahead and move on to the next thing, and that is polynomials. Now here, I'm going to go ahead and let's do this. I'm going to move over to the internet. Okay, just to show you the difference between poly and mono. So you can always do this. You know, I would suggest you do this too. So I already have it kind of written out. So here I have an internet search already going. So mono. Mono means 1. So a monopoly, again, is controlled by one person or one company. Monologue, speech given by one person. So like in a movie, when somebody is talking to themselves, it's considered a monologue. Monorail, a train that uses 1 track instead of 2 tracks. Monotone is using 1 tone, or I think we get like a, well, anyway. Monotonous, using 1 tone. Monosyllable. I know the word is monosyllabic, but monosyllable. English is weird because if you add or subtract just 1 letter, it changes the entire thing, like geometric and geometry. Change 1 letter, the whole thing changes the pronunciation. So anyway, those are just words that have mono. Let's go ahead and put the word poly and see what we get. So poly means, well, polyester and polyethylene come to mind for the definition, but it means many. So like polymers are like many different kinds of materials put together. Let's see what else is let's see, poly prefix. So again, poly means many. Poly prefix words. So let's see what are some words that start with poly. Polygon has many sides. Polyhedron is a three-dimensional figure that has many sides and edges. Polynomial, many terms. Hey, there's the word we're actually looking at right now. Polysyllabic, meaning many syllables. Here's just some other words. Polythene, polyester is clothes made of many fabrics. But yeah, poly means many. And mono means one. So a polynomial is the sum or difference of many binomials. So basically we just add more binomials. All right, so let's go ahead and get into classifying some of the polynomials. That was one of our objectives. The highest exponent of a polynomial is called the degree. I know sometimes in English, not only does the pronunciation change with a single letter added or subtracted, but a lot of words have multiple meanings. And one of those words that has a multiple meaning is degree. So a degree, like 4 different definitions come to my mind. As a math person, a degree is something like 360 degrees makes a circle. Okay, but that's not what we're talking about. Degree can also be a measure of temperature. All right, so temperature, preheat your oven to 250 degrees. All right, but that's also not what we're talking about. We're not talking about angles, and we're not talking about temperature. So think of it like, well, I guess there's also one other one I just sort of thought of just now, and that is degree, as in like when you complete school, you get a degree. But actually that's kind of the same thing as the other one. A degree is kind of like a grade. So with degree, there's like burns, okay? That's one of the other ones that comes to my mind is a burn. First degree burn is usually just, your skin is a little irritated, it turns a little red, it might hurt to touch it, okay? Second degree burns, and I'm not really sure if this is what it is, but it's usually a little bit worse. I think it might have like blistering or a little bit of light skin damage. But a third degree burn breaks through the top layer of the skin into the lower layers of the skin. So basically you actually have entire pieces of skin removed. So that is a third degree burn. So it's like a grade of type of burn. Or you could think of it like martial arts. Okay, someone might say, I'm a 10th degree black belt. Okay, so there's many different kinds of black belts. Once you've mastered, the sport, you get different degrees of that black belt. So that's the one that you would go with. That's the definition you go with, like a grade. So let's write it in standard form, and always write with the exponents in descending order. Write it with the exponents in descending order, which is kind of what we've always been doing. We've always wrote from highest power to lowest power. Think of like the quadratic formulas that we've been working on, so the quadratic equations, right? We got to put them in standard form first, and that means descending order. But instead of just having 2 power, we may have expressions like this one that have 5 power. Okay, that's a lot of power. Now, in this case here, we have 1, 2, 3, 4, 5 terms. So a term is anything that is separated by a plus or a minus. So here we have a binomial, 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 binomial. But since they're all together, that's going to make it into a polynomial. So here, let's go ahead and write this in standard form now. What we got to do is start with the highest power. So look for the term with the highest power, which in this case is negative k to the 5th power. Okay, and then we work our way down. So go down, look at the 4 remaining ones. Which ones? So we have 0 power, 1 power, 3 power, and 2 power. So in this case, we do not have a 4th power, so we skip 4 and go to the next one down, which is going to be 3 power. All right, so the next one below that is going to be this one here. Now I can't write fractions, so I'm gonna go ahead and just not write it as a fraction, but I'm gonna use the decimal form of 1/4 or 1 divided by 4. Just because, okay, just because I can't make a fraction. All right, so there we go. And now after this one, we have 3 terms, so we have 2 terms remaining, 1 power and 0 power. So let's go ahead and we're gonna do it the 1 power. And again, if it's 1 power, we don't need to add the power on there. But yeah, this 8K would be considered a 1 power. Now you might be asking yourself, why is this considered a 0 power? Now, if we look at our zero property, 0 exponent rule, any number to the 0 power is equal to 1. So even if I have 7x squared to the 0 power, it's always going to be 1. Now there is one exception to that, and that is 0 to the 0 power should be undefined. Because if this were true all the way around, 0 to the 0 power would be 1, and that doesn't make sense, because how is 0 times 0 equal 1? So that's why we have to say that that one's not allowed. But anyway, anything to the 1 power, or sorry, anything to the 0 power is just going to be 1. So here I can replace this with times 1. K to the 0 power is just 1. Times 1, I should say. Times 1. 1 times 1 by identity property means that it's just going to be the same number. 1 times 1 is, well, 1. Or in this case, -1 times 1 power is 1. Okay, whew. So there we go. That's in descending order, so going down in power. So let's go ahead and start with the highest power of this one. Now this one's a little bit of a weird one here because it's recommended that I have something else here, but let's look at the degree. What degree is this? So kind of to make things a little bit easier, and this is something I usually show younger kids, but maybe you could benefit from it as well, is to circle the terms. So I'm going to draw a little circle around each of the terms. 1, so that I can see where one ends and the other begins. And 2, so I can see how many terms I have. So in this case, I have 4 terms, and I'm going to write a little number on top talking about the power. So this is a 4 power because 2 A's and 2 B's, the whole term altogether has 4 exponents. So that's why we consider it a 4 degree. This one is going to be a 2 degree because I have 1 A and 1 B, or A to the 1 power, B to the 1 power, which means I have 2 variables that are being multiplied, which means it is a 2 degree term. This one is also 2, and you might be looking at this thinking, oh, well, we have a tie. What can we do? I'll show you in just a second. This last one here is a 3 power because it's, well, this one's obvious because you can easily see the power is 3. So let's go ahead and type this in order. Now, obviously the 4 power is going to go first because that one is the highest power, no questions about it. Now, here I have 2 terms that are, well, hold on a minute. I have a 3 power here, so this 3 power should go next. So plus 4a to the 3 power. Now, I am going to go over here, and I have 2 powers. So if there's two powers, how do I arrange them in order? So if two terms have the same power or degree, you go by alphabetical order. So this one does not have an A, but this one has an A. So I'm going to make the A go first. So even though it's 2 power, it beats out this one that has only B. This B is only a 1 power. I mean, sorry, these last 2 are both 2 powers. But since, even though B has 2 and this one has 1, it goes by alphabetical order. So this one only wins out because it has an A, so that's why it goes first. All right, maybe a little confusing, but it is what it is. Okay, now let's go ahead and move on to the next thing here, which is what we have here. So again, I'm going to circle this, all of these. All right, and now I can see that I have 5 terms, and I need to find out the power on these terms. So let's go ahead and I'm going to write out the number of power, or the degree. So this is 3 degree, 2 degree. And this one has 3 here, 1 here, so that's going to be 4, because again, you combine all the exponents together. 4, and this one has no variable, so it's considered a 0 power. Now, 0 power is not the same as 0, because remember, 0 power just means basically it's the same number. It's just the exact same thing. So I'm going to go ahead and type this out. So I have 2 4 powers. There are 2 number 4 powers. So again, we go by alphabetical order. Which one has the higher number of x's? 9x to the 3. That's probably what I was thinking. Y, and then minus. Let's see, here I have the next term, so this is minus y to the 4th. So those are my 2 4 powers. Let's go ahead and move on down to the 3 power. So this would be plus 5xy. And it's positive because of the, not because there's a plus, but because it's positive. You always add the positive terms. And let's go ahead and move on down to the next one. So this would be minus x squared plus 2. There you go. So now that is in the correct order. Now this is a fairly long assignment, so I'm going to go ahead and split this into 2 separate units, or 2 separate lessons in a way. And I am going to cover this next one because in the homework packet, you would be done with this page basically. So we're going to make this the last one. We'll take a break and continue tomorrow after this page. So classifying polynomials some more. So we classify them by the degree, which I've already kind of covered for the term. But now we're doing the degree of the entire polynomial. So degree of the polynomial and the number of terms. We're going to use this chart to basically classify these polynomials over here. So going by the degree. So in this case here, look for the highest power. This is a 1 power. So we would call this linear. So if we were working on a function, this would be a linear function. In fact, if you look really closely, it does look like y equals mx plus b. Now here's another word that we've been using, and that is the number of terms. So in this case, this is a binomial. There are 2 terms. So a binomial, think of like the word bicycle or binoculars. So a bicycle has 2 tires. All right. So binomial means 2 numbered, or 2 numbers, which this one does have 2 terms, 1 right here and then 1 right there. All right, so let's see, look at this one here. So look at the highest degree, the power, 5, 4, 1. So this is a 5th degree. So we call this quintic. I don't really need to put the capitalization there. It's not a proper term. So it's a quintic because again, it's a 5th degree. And the number of terms, how many terms are there? 1, 2, 3. So there are 3 of them. So this is a trinomial. So you might think of like a tricycle or a triceratops. So tri means 3. Here I have a very simple one. It is, you're going to need to copy these things down too. But here we have 1 term. So we only have 1 term and no power. So this is what we call a constant. Constant means it doesn't change. So a variable, you're familiar with variables. You can plug in something for x and you will get a different result. Constants do not change it. They don't change, they just remain constant. If I make x equal to 1, it's not going to change it if I make x equal 10 or anything else. It doesn't change. So that's what we call a constant value. And 0 degree are constants as well. It's also a one term, so this is a monomial. I pronounce it both ways because I don't know why. But I think most teachers go with monomial. And I really should stick with what they say, what everyone else says, because I don't want you going to other teachers and saying monomial, which is the way it should be. So here we have x to the 3 power. So this means it is a cubic function or cubic degree. So 3, 2, 1, 0 power. So it's in order. And there are 4 terms. Now, mono, again, means 1. Bi means 2. Tri means 3. And poly just means many. So we don't really need to go into more of those. So we can just say polynomial. And anytime you have more than 4 terms, so this is 4 plus, you just say polynomial. If there are 7 terms, you call it 7-term polynomial. Okay, very creative, I know. So anyway, there we go. And that's pretty much all you need to know about this. And again, degree is constant. 1 is linear, because like if you imagine a graph, it would just be a straight line. Quadratic means there's 2 of them. Cubic means that there would be 3 of these. 4 power, now we're not quite into functions yet, and I'm not sure if we'll be able to get to them this year, but quartic means that it has the potential of 4 solutions. Quintic means that it has a possibility of 5 solutions. So we've been covering a lot of quadratics lately, and we are aware that quadratic means there might be more than 1 solution. In fact, there's usually about 2 solutions. So until next time, goodbye, and I will see you later. I guess that works out.